I want to talk a little bit about doing the data science in the cloud. So you might have, I'm sure, have heard about doing data science on your machine. Is this thing working?
That won't work.
That
won't work with your Mac.
Yeah. Oh, no?
I know because I tried with mine.
I will go manual.
Sorry.
That's okay. I had to at least give it a shot. So most data science projects or machine learning projects are done usually on somebody's laptop, and then what ends up happening is they stay on that person's laptop for good, and that's how most data science projects fail. So one way around that is to take the laptop out of the equation and build it somewhere where you can share your development. So that's kind of what we're going to focus on today. So just a quick agenda. I'll be doing the first part, and then my friend Tom will come and talk about IBM Cloud, and then I'll come back and do a demo of. We're going to build. We're going to build a couple of models in Azure machine learning from scratch, and then we'll productionize one of them and build a web service off of it. So I plan on going through the whole gamut. So just something to kind of keep you from leaving in between meetings, or in between presentations. So we'll leave the best, or leave the demo part to the end so that you guys can at least see something working within Azure ML. So yeah, data science to the cloud. Most data scientists usually have the following tool sets that they need to know, whether you have to be able to program in R or Python, you have to be strong in SQL, understand structured and unstructured data. Usually they come from a data analysis background, but now they also need to be able to understand how to execute scripts at the command line using a cloud platform. So that's something that's new, that's come out in the last, probably I would say in the last 4 years, where cloud has become more mainstream. You're able to run virtual machines on the cloud, and now you can run predictive models directly on the cloud. Back in the day, before there was even machine learning, if you were just a statistician and you were running a model, it would probably take you about several hours worth. You would probably be in a lab somewhere. You'd run your model, you'd go home for the night, you'd hope that the janitor did not tip over the wires and kick off and turn off the power to your laptop, or else you'd have to kick off that model again the next day. And I'm actually I'm not trying to be sarcastic, that's literally how things were, because the models that were run were not even run on large data sets because you were limited there, but the resources that most machines had were just so limited that something now that would take a couple of minutes probably took maybe half the night, maybe 10, 15 years ago. So we're not talking about a long time ago. So the resources for data sciences were just resource intensive. So something had to give. You would either, if you're going to build your model, you either have to take away some of the data, and that way you would limit the ability. Thank you, Hunter. Let me just take off the notifications if I can.
They're not showing up for us, by the way.
Oh, they're not?
Yeah, we don't see anything.
That's well, I'm just trying to, just 1 second. I am going to, I thought I had it off. Disturb.
Should we start tweeting to you?
Yeah. Send me the tweets at do not disturb. All right. So something had to give. You either have to limit your data set, which obviously the more data you have, the better your model is going to perform, the more robust it will be, the more likely you are to pick up outliers or at least detect outliers. Or you would minimize the complexity of your data. So you would take out certain parameters that you wanted to measure just because it would allow your model to run faster. So you're limiting the innovation of your model or the flexibility of it. So they started building laptops and machines that can handle data, because you can now have a 2 terabyte hard drive that's solid state, or you can buy up to 32 gigabytes of memory and put it in your laptop. Problem is, you're looking at about at least $4,000 for a machine like that. You could do that same type of work if you were to build that model, instead of doing it on your local machine, doing it within a cloud service, you could do that for about $30 to $40 a month. So if you took that over the course of a year, that would get you to about maybe almost a little bit less than $500. So that's, we're talking about 8 years worth of cloud service for what you'd be spending on a laptop. So there's that trade-off now, that you can do that stuff locally, invest up front, or you can invest as you go. And if you're not using it, you don't have to pay for it. Additionally, if you're following the whole craze about deep learning and building models based off of images and trying to do facial recognitions or voice recognition, all that requires additional memory, additional resources that certain machines just don't have. GPUs have now become the way. If you do any type of gaming at all, then you understand what the power that a graphical processing unit has over a regular CPU. So if you just see the amount of cores that a regular CPU has versus the one that a GPU has, you can now use GPUs on your machine to run models on top of. Problem is that most people don't buy their laptops with even the basic video graphics card. You can incorporate that into your cloud platform, and you can add resources for GPU units instead of CPU units for just a short period of time, and you can get better performance for running larger data sets. Some of the things that are now picking up with AI and deep learning, where you're trying to detect, really important things like, is this picture of a cat or of a dog, or a person's, features. Is this person my sister or is it my cousin on Facebook? I mean, that's all done with GPUs. And the reason why they can do that is because they can take huge batches of data and they can execute the operation over and over again very quickly. Whereas the CPU is really good at taking a small operation and running it, running it over a few threads at a time. So if you try to run a model on a GPU and then run it on a CPU, you'll actually see that at some point your machine is just going to, it's not going to know where to go, and it just freezes. And most of the time when you're working, when you're playing a video game on your laptop and your computer freezes, it's just because your machine is trying to run a process that a graphics card is used to, but a computer processing unit is not used to. So when you're working in the cloud as a data scientist, or even generally, you're free from those local constraints, and you have the ability to also be collaborative. So you just log into a website, you can develop something, and then you can hand it off to your partner, and they can start from where you left off, and so multiple people can be within the same development environment without having to worry about installing anything locally. Most of the time, people who are trying to get started with machine learning, the most difficult thing they have is just getting a setup installed on their machine without having any issue. I was working with a colleague of mine here just this week who was trying to do some text analysis on a speech by some politician, and he was trying to install this package, and I was telling him that it was working fine on my machine. He had a Windows and I had a Mac, and so the path, the documentation to install it on mine was slightly different. He couldn't get it to work on his, and he spent the whole week trying to get it to work and with customer support, and it still didn't work. So that's a barrier that people face that sometimes can stop you from doing something where you want to be working on. And so having that environment pre-set up for you and pre-installed is a barrier that's taken away that can get you quicker to your end result to see if something that you've been thinking about can work or not. There are some disadvantages to working in the cloud that still have not yet been sort of rectified, and some of it is just natural. If you're working on the plane and you built a model online, you would have to work on somewhere where you can download that model locally and work on it. Otherwise, what's online is online. You're not going to be able to access it. And sometimes for security reasons, some companies shut that down and they just won't let you go online, so you do have those restrictions. There are also some compliance thing. If you're working with companies that are regulated by the federal government, they will not allow you to use models that are based off of custom coding that's not been vetted. So if you're building a model and it works great, but it hasn't gone through the proper channels, some companies just won't run those models. So you're more likely to get acceptance if you can show them that it's a model that's been built by like a Google or a Microsoft that's gone through the proper auditing process. So there's still some legal issues here and there, but it's every year it seems to be getting, the barriers of that seems to be getting smaller and smaller, and most companies are becoming more apt to letting customers use, or letting their employees use cloud computing and cloud solutions. So let's look at some of the, I'm not looking at all of them, I just wanted to look at 3 that are commonly used in conjunction. So the 3 that have the machine learning capabilities that I wanted to compare were Azure, AWS, and Google Cloud. And the reason why is that you work with all 3 of those, so I can speak a little bit in terms of what are the advantages and disadvantages to each one. Tom later is going to talk about Watson and the data science experience, which has its own advantages that IBM is rolling out as well. So 2014, AWS was kind of on its own and everybody else was trying to play catch up. Nowadays, though, that gap has shrunk because other companies now are getting into the game where they're building their own models and they're building their own libraries, and then they're becoming accepted as part of the norm within machine learning. So Google has introduced TensorFlow into the market, and when Google introduced TensorFlow as a deep learning library, it actually wasn't initially used for deep learning, but it became used for it. Google Cloud became a lot more popular. Microsoft started introducing CNTK and other types of natural language processing libraries. Microsoft Cognitive Services became a much bigger deal. Microsoft Azure Machine Learning became a lot popular. So what's happening now is that if you're able to offer your own solutions for your own libraries, the cloud computing, the cloud services become much more in demand because companies start taking you seriously. That you're not just delivering the service, you're delivering also the product. So let's take a look at AWS. AWS has probably been it's the one that was the first responder. It was the first in the door, so it has a lot of market share. A lot of the companies that are out there, like the Netflixes, use AWS. They load their data into Redshift or RDS. Their models are very automated, so basically you deploy your data and it detects for you if it's a categorical or numerical data set. The modeling, though, is a little bit out of the box. It's only dealing with supervised learning models, so it doesn't yet support unsupervised learning out of the box. It does support unsupervised learning if you bring in other libraries in there, but basically, not to get too much into the weeds, but supervised models are models where you know the outcome that you're trying to predict. Unsupervised models are where you don't really know something yet, you're just trying to see if there's a relationship. So clustering analysis is a very common unsupervised method technique. Whereas supervised would be like your binary, your classification and your regression, which are the most common types of predictive models. So out of the box, AWS only supports binary, or only supports classification and regression. Google Prediction API is kind of the same thing. They offer only out-of-the-box classification and regression. They do have some pre-trained models that are already built and some templates that you can use to sort of copy and mimic and build your own model off of it. So if you don't know exactly what you're doing, but you saw a model that looks like something you're trying to solve, you can copy it, take out that data set that they had, bring in your own, and then tweak the model a little bit and see if you get similar results. Azure has a bit of a more manual operation as opposed to Google and Amazon. So it's not going to do what we call automated analytics. You don't just upload a file. You do a little bit of steps where you're building it. But that step process, that development process is sort of linear in the sense that you can see the model building from step by step. So there's a nice workflow that's very graphical. So if you're used to Visio or PowerPoint, you can work with Azure ML. If you hate PowerPoint, you'll probably hate AML too. But it just depends, how you feel about them. But it's got that comfortable user interface that you're used to with Microsoft. The other thing that Microsoft does well is, whereas the other two only supported supervised learning, they support both supervised and unsupervised models. So that's an advantage. They also not just have regression and classification out of the box, they also have anomaly detection, recommendation engines, text analysis out of the box. We talked earlier about CNTK, so that's one of the things that Microsoft offers you without having to do any type of custom coding. So that's, again, very helpful. Yes, Tom?
Sorry, question. Supervised, unsupervised.
Yes.
What's the difference?
So a supervised learning model is, so if you wanted to measure, like the example that I'll cover later is measuring customer churn. You already know that you had 100 customers last year churn. For example, if you had a thousand row data set.
You have historical data on that.
So you have the historical data, and you know that now you want to build a model that says, let's develop a model that can tell us future churn. So you know what your target variable is. So you have information like how old people were, what kind of products they had, and then you're trying to see if you can relate that to an outcome, right? An unsupervised model would be, I have that same data set. I don't necessarily care if they churned or not. I just want to know, are there common relationships amongst the different people that were in this data set that I'm not aware of, just by doing a visual glance of the data. So maybe it'll show me that of all the people that purchase certain product, they all also fit within a specific age range or a specific educational background, or they lived in a certain part of the country. So if you can see like that type of clustering on a data set, you can then identify certain features that maybe did not show up right away.
So is there like that diapers and beer use case?
Yeah, that's a very common one.
Okay.
Where people who go out to Target and they buy certain things in conjunction with each other. So that's a good question.
Can you talk a little bit about text analysis? What is it trying to correlate, free-form text amongst different people to see if it's copied, or is it trying to find patterns within answers to questions? What are some of the use cases there?
So text analysis is pretty broad. It can do, basically anything where you're trying to understand. It can be from understanding the sentiment of the text. So you're trying to understand if they're using words where it's describing a problem, or if it's describing a certain product. So you want to understand if there's a certain specific focus to the text. You're also able to identify just the frequency of words. So if you want to do like a word count, excluding certain stop words are like the and we and I that you want to take out, and you just want to focus on specific nouns. So just a general word count if you want to query on a different area and just get a quick overview of what are the words that are being used. What are the complexity of the words? It's very useful when trying to understand bilingual analysis. Are certain people speaking a different language than others in certain areas? So it's able to detect origin of the word, that type of thing. So those are some of the text analysis features or text analysis services that Microsoft provides out of the box.
Thank you.
Yes.
Do you know if that text analysis by Azure is that supervised or unsupervised?
Text analysis is generally it doesn't really fall, I wouldn't say that it falls under, if you're doing it for sentiment, then you're trying to find a score, then it would be supervised.
Yeah, but I'm specifically interested in Azure. Does it just do that kind of stuff?
If you're doing segmentation and clustering, that's by default an unsupervised model.
Right. So Azure does that.
Azure does do that, yes.
Okay.
Yeah. Oh, that's a good question.
I've got a question. So
yes, go ahead.
We do a lot of combining data sets, because data sets, I always refer to them, one is in Hebrew and one is in Chinese, right? So you're trying to combine the two so you can have a larger table to do analysis from, we use string distance to do that. How would I do that in a tool like this? We would call in like Levenstein distance, a package in R, to do the scoring of the combined value that we want to compare. Would I be able to do something like that in this tool?
Yeah, you can do that. I mean, as long as you can. I mean, you're asking if you can bring in different languages.
I mean, all the time, we're asked to build big data sets because we want lots of variables to use to formulate a model and predict from, right? So, but you got to construct them and put them together.
Right, and you got to be able to structure them in a way.
Right. We use text mining to agree that we have found a common record, and we're going to add those characteristics together. So now we have what we believe to be the same record. We have 200 variables, right? So, could I do something like that in this?
And I would say theoretically you can. I have not gone in there and tried to do something like that myself in text analysis within Microsoft, but I know that there are packages that do that. What Azure and what some of these other tools do is that if you can't do it out of the box, you can always bring it into with a script within R or Python and work with it in there, and just use Azure as your wrapper, where that's where you're executing the code. So yeah, I mean, in theory, it sounds like something that you can do. I can't tell you for sure if that's something you can do out of the box, 'cause I have not done that myself.
But I am curious, say I'm fitting a model, does it give me different having models to choose from?
Yes, it gives you tons of models you can choose from, and then you can evaluate them. Simultaneously.
Okay.
We'll go through an example like that today. We'll build two classification models, and you can kind of run them in parallel, and then you can tie their score at the bottom and see how they do with each other. Azure also has something called the Cortana Intelligence Gallery, which allows you to, similar to Google, you can look at a bunch of solved predictive models and see how it was built from scratch and just look at the workflow. You can either copy that and use your own data, or you can try to mimic it your own, or just see how people did different solutions. So if you're looking for something that was done with text analysis, you can filter in the gallery and find those solutions. Anytime you build a model, you can publish it into the gallery, so it becomes open to the public. Other people can see it. So it's very easily, you easily share your results as long as you want it to be shared. The other thing that team data science is something that Microsoft came up with just recently. And so if you look at this statistic, I was talking earlier about why some data science projects do fail. And from this 2014 report, it said that only 27% of big data projects are regarded as successful. Only 13% of projects or organizations have achieved a full-scale production of their big data implementations. Only 8% of those are considered very successful. And then only 17% of the surveyed respondents said that they had a well-developed predictive or prescriptive analytics program. And why is that mainly happening is because most data scientists in the past work in silos. So they work in silo in the terms of within their organization. They're sort of like stuck in the corner, and they're doing their thing on their laptop, and they're not really sharing their results. They're also stuck in the corner because some of the tools that were developed for open source, they're not really enterprise friendly, so you can't really deploy an R script or a Python script into production without going through a bunch of reworking and a bunch of changes to your code, and that becomes an issue where you want the final product to match what you were developing on your laptop. So that silo effect is what's been causing some of these projects to fail. So in April of this year, Azure released something called Microsoft released something called the Team Data Science process. So it's basically an iterative solution that allows you to take your code that you were developed and allow it to be shared through a total lifecycle experience. So if you're used to working on a BI project where you have something that's in development, goes through the chain of command, and then ultimately is deployed into production, now they're starting to develop that type of software for data science projects as well. So what that ends up happening is you create a standard data science lifecycle, a standard template for documentation, structuring, and reporting. a standard infrastructure for code repositories and source control. And then those tools can then become like a checklist where you're able to see what's been done, sort of like if you were following an agile methodology through the development, QA testing, and production process. So that's kind of been something that Microsoft acknowledges as one of the reasons why certain data science projects fail, and they're trying to implement that within their Azure and machine learning workflow. And that's kind of helping projects become sort of follow a standard procedure and reach a production-friendly stage sooner than later. So the key takeaway is from this: if you want to upgrade, if your boss comes and asks you to upgrade your laptop next time, you might want them to tell you to get you an iPad Pro or a Surface notebook, and then have them just pay for a monthly cloud subscription. You might actually get more benefit by doing that. You can just run your model and log off and let all the processing occur directly on the cloud. Any questions? Yes.
Do you have any experience with SaaS Enterprise Miner and their cloud offering outside these three big players? Follow-up question to that: do other software providers of machine learning, such as could be R or IBM Modeler, do they also do other cloud offerings on their own too?
So I'll leave the IBM question for Tom,
Okay.
because he's got expertise in that area. But I have worked with SaaS Enterprise Guide and SaaS Enterprise Miner, but I haven't worked on the cloud versions. I've only worked on the local version, so I couldn't really tell you SaaS's solutions for machine learning for the cloud. I know SaaS has a new product called Voya, or Vaya, I think VAYA, that's coming out, or has come out. That's supposed to be the next offering, but I mean, I've used SaaS. I liked it. My only issue with SaaS in general is some of the code that you would work on was not was proprietary in the sense that you're developing. So if there were any issues in terms of how the model was built and why certain parameters were affecting the weights a certain way, it's not something you can easily go in there and be able to identify. So actually, I used SAS mainly a lot for writing scripts, SQL scripts, and then I would take the code and most of the code I would run for the models. I would do it in Enterprise Miner and not Enterprise Guide. In Enterprise Guide, I use it primarily for data manipulation, which SAS is really good at.
On the IBM side, I'm going to talk about data science experience a bit. That is something that is available on-prem and in the cloud. So you could do something like that. Okay, but I'll talk about that in a minute. So.
Yes.
The big concern is security.
Mm-hmm.
So you're working in a big organization where all the scary things and scary people are in the cloud, right? So for me, to go and argue to go to the cloud requires me to go before 10 committees. Do you see that changing in the future? You have big applications like Salesforce. They're very successful and they're widespread, and they're helping us make the argument for movement to the cloud. And AWS is taking off, but it's still a struggle to get to the cloud. Do you see that too?
I've seen a big change in that since 2014 up until now. So 2014, if you told me that more and more BI companies or companies that were investing in BI were going to be moving to the cloud, I would have probably said I'd have to see it first to believe it. But now, from the way I'm seeing things, if your company is trying to keep up with how the technology is changing and how more and more companies are going with automation and trying to build models to simplify the workflow process, you're just not able to do that type of work on-prem anymore as you used to, because the volume of data that you need sometimes exceeds most companies' resource limitations. So they're just not able to keep up with what's coming out. So what a lot of companies are doing is they're using cloud as a supplement to that, and to just focus on one or two solutions on the side. And when they see some success with that, then it kind of opens up the floodgates in other areas. Usually, though, it's within a certain part of the company that's not that's where security is not as big of a concern. So it's usually with either public data or data that's not, that doesn't include, personal information, that type of thing. So that's usually how I see companies who want to get in, want to get a foot in the door, but don't necessarily want to, go all in because they're afraid of some of the concerns that you brought up.
I think one of the other big things is when we talk about cloud security and on-prem security, sometimes the cloud is more secure. There's less risk by going there. People made that argument to me all the time, and I'm like, no. But now you're seeing some of these bigger companies getting hacked internally, right? So that doesn't necessarily always happen in the cloud because you have an extra layer of security. Plus, you can go private cloud, right, where you still maintain all of the infrastructure yourself. You can go hybrid, where you're keeping your data on-prem, but just using the platform in the cloud, and your data never leaves, and you're secure that way. There's many different ways you can skin that cat. But like Ahmed said, a lot of the way you can get started in there is maybe working with a backup or a disaster recovery site in cloud and see what benefits you can get there. And then that kind of opens up the conversation with some of the more mission critical applications.
What's happening to the BI guys? So I go before a committee and argue to go to the cloud. My BI guy is kind of sick of me now, right? Because he's in Oracle 11G and he's trying to get my business into Oracle 11G. You see what I'm saying? But what is really going to happen to the BI people that are invested there as we see computing far more effective in the cloud?
I got the answer to this one.
Okay.
Give him my business card.
Oh, okay.
So a good example on this one is, especially working with a group like CCG, part of what we're doing is we're always retooling the people we work with. Every single individual this year, we've hired some fantastic SAP guys right off the gate, and then immediately they're working in Power BI. So what's going to happen is the same thing that happens with technology. No matter what technology you use, every 2 years things change. So anybody that's doing any sort of BI work is going to be doing it, but in the cloud, where there's going to be more efficient horsepower coming out of the servers. It's not going to be bottling things down for you guys. Your queries that you're running aren't going to be taking your servers and taking them down. It's going to be going to the cloud. So the same thing they're doing now, they're going to be doing, but with maybe a different certification.
There also are NSPs that have all of the sufficient security clearance. Instead of the U.S. government would accept Verizon as the NSP that offers cloud services. That's what a lot of companies and government entities will do, is they'll rely on MSP.
And I think Azure just got certified with GDPR recently, so that's the European federal government entity on governing data and how it works, and they are now secure with that. So they got certification for it.
And if I recall, Europe has much higher standards than the United States.
Yeah, to that I can't speak, but
Cool. Any other questions? All right, thank you guys. We'll take a quick break.
Yeah,
Quick break.